Hello everyone, welcome back to ANR Academy. Today we are going to discuss how to find image of given curve with respect to given line. We know that if P x1 y1 be a point, then image of P with respect to the line ax plus by plus c equal to 0, suppose that is Q, then to find coordinates of Q we use h minus x1 by a equal to k minus y1 by b equal to minus 2 of ax1 plus by1 plus c by a square plus b square formula. This is from image theorem. Now, instead of point, suppose if there is a curve and we need image of this curve with respect to a line. Suppose that given curve s equal to 0 and given line L equal to 0. Now let us see how to find image of this curve with respect to given line, that we are going to discuss today. With the help of image theorem, you can find image curve also. Let us discuss with an example. Suppose that if there is a curve y square equal to 2x, if it is given curve, and we need image of this curve about the line x plus y plus 1 equal to 0. Our aim is to find image of parabola y square equal to 2x with reference to a straight line L x plus y plus 1 equal to 0. Yes, to find image curve, I am going to use image theorem. Y square equal to 2x. Suppose that given curve y square equal to 2 times of x. Next, given there is a straight line whose equation x plus y plus 1 equal to 0. Assume that this is the line whose equation given x plus y plus 1 equal to 0. Now the aim is to find image of the given curve. Yes, image of this given curve y square equal to x. You will get its image in this way. So here it is the aim to find the equation of image curve. This one is image 1, image curve, and that is given curve. Yes, to solve this, first I am going to select a general point which lies on given curve. General point whose coordinates, suppose that x comma y. Every geometrical figure is collection of points which satisfies a consistent geometrical condition. So in which locus point, if I select P x comma y, then we know that automatically its image that should be lies on image curve. So here you will get image of P. Suppose that that is some P dash, and assume that whose coordinates h comma k. Here x comma y locus point of given curve y square equal to x, and P dash h comma k. Here h comma k the coordinates on image curve, and hence image curve should be finally in terms of h comma k, and replacing with x comma y we get equation in terms of x and y. P x comma y be a point on given curve. My aim is to find first p dash, and from that the relation between h comma k we get image curve. Here if p x comma y be a point, general point on the curve, then the relation between these two coordinates you have here y square equal to x. This is equation of given curve. Just find image of p with reference to given line x plus y plus 1 equals 0, and after that if you write the relation between h comma k, that is the equation of image curve, right? See here, p x comma y, that is locus point on given curve, and here straight line whose equation given as x plus y plus 1 equal to 0. Now my aim is to find coordinates of p dash. I am going to use image theorem. We know that h minus x1 divided by a equal to k minus y1 divided by b equal to minus 2 of a x1 plus b y1 plus c whole divided by a square plus b square. This is the formula. Image point whose coordinates h comma k, but given point whose coordinate x comma y, and straight line general form ax plus by plus c equals 0. Here a, b, c are 1, 1, 1. Replacing the values in this, we get h minus x divided by a, k minus y divided by b, that is 1. Next minus 2 of here ax plus by plus c, that is x plus y plus 1 divided by a square plus b square, 1 plus 1. H comma, in the theorem h comma k image point, x1 y1 given point, and mirror straight line ax plus by plus c equals 0. So applying image theorem, we got here the result h minus x equal to k minus y equal to 2 gets cancelled, minus x minus y minus 1. Equating these two, minus x gets cancelled, we get h value minus y minus 1. Next, equating these two, next we get minus y gets cancelled, the value of k become minus x minus 1. You have the relation between the coordinates x and y here, and applying the relation in this case, here you have left hand side y square, in the right hand side you have 2x. I am going to write the value of y first. From this, y can be written as minus h minus 1. Next, x written as minus k minus 1. Here you have the relation between coordinates x comma y. Replacing x comma y values, minus h minus 1, that is in place of y, minus k minus 1 in place of x, then automatically we get another relation that is in terms of h comma k, that gives image of given curve. Yes. Now here I am going to write the value of x and y. Yes, you have y square equal to x, y value whole square equal to 2 times of x. What is the value of y? Here you have minus h minus 1, and what is x? Minus k minus 1, that is h plus 1 whole square become minus 2 of x plus 1. So this is the relation between h and k we need. Here this one is not x, this is k. Finally we got a relation in terms of h comma k, that is image curve. So that I can write here image curve h plus 1 whole square equal to minus 2 of k plus 1. This is your answer. So in this way we can find image of given curve with respect to given line. Let us see. Suppose if there is an incident ray and mirror line suppose given, then to find reflected ray you can use the same concept. Why? Because incident ray, that is equation of line, this is incident ray, and this is mirror line. Here the requirement is reflected ray. The same concept we may use to solve reflected ray. Incident ray is given. Image points with reference to mirror. Here the collection of points you have here, 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 here and here, right? Now image of all these points with reference to this mirror, its image you will get here, image of this point here, image of this here, image of this point, image of this one, image of all these points we get here. So that incident ray, reflected ray, those you have here. Observe red colored points which are collection of points on incident ray, and yellow colored they are points on reflected ray, and clearly those points, required points which are lying on reflected ray, they are image points with reference to mirror. So just select a point on incident ray and then write image theorem. Select a point h comma k on reflected ray, required one, and write finally the relation between h comma k that gives reflected ray. Not only this, suppose a third degree or fourth degree, whatever. Suppose there is a curve given and mirror line, suppose this is L equal to 0, this is S equal to 0 and it is L equal to 0. And here the requirement to find image curve. Assume that some S dash equal to 0. To find S dash equal to 0, that is to find image of given curve with reference to the line, just select a point P whose coordinates x comma y on the given curve and find its image whose coordinates h comma k. You have here a relation between the coordinates x and y. S equal to 0 indicates a relation between the coordinates of P. Just to find image of this point P with reference to the line, then you will get the values of h comma k which are in terms of x and y. H comma relation if you made with the help of inverse theorem, then that is the equation of image of given curve with reference to given line. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.